Hello everyone, and welcome to part 2 in the series Let's Build a Tool Changer. This is based on the WP-DAKSH tool changer that I've designed, which can be integrated with multiple CoreXY systems. In this part of the video series, we will be looking at the Carriage Assembly and the operation of the tool lock mechanism. There will be a detailed guide on how to put the carriage and the tool changing mechanism together and install them with each other. Before we actually dive into the actual build process, let's just take a couple of minutes to review what the tool changer carriage actually looks like. So as you can see on the screen, the carriage is comprised of two main sections. One is the carriage, which has the belted gantry, and this is based on the Voron 2.4 carriage. The belts come in from these two holes. There is a probe for the auto bed leveling and the virtual Z setting. In addition, there is a tool lock mechanism on the back that comprises again of a set of parts. All of these parts are printed. There is no metal part involved in this except for the fasteners and some linear rods in there. The MGN 12H block is what is used to mount the carriage onto the gantry, and the tool lock mechanism is operated using a servo that rotates this eccentric horn, which in turn pushes the cam lever up and down, eventually opening and shutting off the lock mechanism right here, which is controlled with a spring. So it's a very simple operation in process, but it has delivered consistently good results during tool changes in all my testing. There is of course a part cooling fan gantry, part cooling fan on the gantry, which is comprised of these two legs and then a 50-15 fan that is mounted up top. So now that we've actually reviewed the way the whole carriage and the tool lock mechanism is put together, let's go ahead and assemble it in its flesh. And we will be using printed parts that I already have printed to put this together. I hope you guys like this video and consider building a WP-DAKSH tool changer. So the main carriage consists of two parts. These two parts go together like this and they get seated on the MGN 12 rail using the 4 screws here. There's a probe that goes in here, and there are other bits and pieces. Then the locking mechanism attaches to the main carriage here, which we will assemble next. So moving on to the assembly of the main carriage, there are a number of heatset inserts that need to be put in. I think about 11 or 12 in total for these two parts. So we'll start off by installing the heatset inserts. So as you can see, we installed I think 6 heatsink inserts in total. 1, 2, 3, 4, 5, 6. This one tends to come out a bit, but you can just flatten it, and if possible just take a file and smoothen out the part. This is going to mate with the servo holder, so it's necessary for it to be flat. Let's move on to the other part. So this part has 5 inserts, 1, 2, 3, 4 and 5. So in total about 11 inserts for the main carriage. Then we have the servo holder. These two parts together form the servo holder, like this, and they attach to the main carriage. So there are, I think, 3 heater inserts or 2 heater inserts that need to go in here. So one needs to be installed here. And then there is another one that gets installed here. Now this one again is a bit tricky because it's right on the edge, if you can see that. So just flatten it out with my own hand, push it in. So that, like this, essentially forms the servo holder. So now in addition, there are 3 other parts that I already have the heater inserts in. These are standard Voron parts. So these are the belt holders for this type of carriage from the initial release of 2.4, and then this is the probe holder that fits in the back of the probe on the carriage. So the carriage goes like this, and then the probe holder comes in somewhere in the back here. So we'll assemble that up now. To assemble the 2 parts together, we need M3 hex nuts that need to go in here. If they're not going in, I would just kind of take a soldering iron and just push them in a bit. That should do it. Depending on the tolerances on your printer, they can go in very easily, and on other holes, for example in this hole, it just kind of went in without any issues. So the third one, again, if it's not going in, I would just take a soldering iron and just push it in. So 3 hex nuts installed on the left part. We take the right part, we couple it up using this notch that is there. So this notch kind of just slides into the other part, and then we have M3 by 30 socket heads that can be used to tie both of these parts together. So it kind of just holds it together and gives it rigidity. should not over tighten it, just tighten it enough so that there is just enough space in there, or enough rigidity in there. And then we have this third one. I think this one will take M3 by 40, I think, instead of a 30. This one will take an M3 by 40. Yep, right here. So that assembles the main carriage body. There is one more thing that needs to be installed on this, which is a magnet, but we will install this once we actually couple this up with the tools, because the polarity on this magnet needs to be opposite of what it is on the tool. So this magnet has a 30 mm piece of M5 let me see if I can just focus it there. Not sure if you can see it, but this magnet has a 30 mm M5 smooth rod with a pointed end. It's going through it, and then it is hot glued together. So the magnet will sit in like this in here, and this is what keeps the bottom of the tool from sliding out, because there's a magnet on the tool that couples up with this magnet as well. So we'll use some hot glue, not so hot glue, super glue. Even this is super glue. We'll use some super glue to actually kind of put this together, and then tighten this nut here to make sure that it actually stays tightened. So the other part of the assembly on the main carriage is the holder for the servo. So the servo holder, the first part goes in like this. Then there's an M3 by 16 that this is supposed to be an M3 by 10, I think, right here. So, or M3 by 10 or M3 by 12. So that is one, and then we have two M3 by 16s that go in this side into the heat set inserts that we put in. So the servo holder in itself is a two-piece assembly to make it easy for the servo to be put in or taken out, and you should just tighten this completely. The top as well. That is one piece, and then the second piece essentially is what the servo gets put into. So we take the servo, we press it in like this. We take an M3 by 6 with a washer. Just let me find that washer right here. tighten the servo completely into this. There's no, the tab on the bottom has to be broken on the servo because this interferes with the belt path. And then it gets assembled like this. So there is an M3 by 16 again, that or I think it's an M3 by 20. Same here. Yeah. So and another one in here. The idea is to tighten the servo down so that it does not move. So just keep both of these balanced. That is how the servo gets assembled into the carriage. So this is how it looks from the front. These two are for the cable chain holder, and these two on each side, they are for the parts fan to be put in. The notch here is for the X end stop micro switch to be put in. Let's move on to assemble the tool locking mechanism. The tool locking mechanism requires these two printed parts that can be combined using this notch, and there are heat set inserts on both the parts, 1, 2, 3 on this one, and 1 and 2 on this one. So we need to combine these two parts together. There is an M3 hex nut that I've inserted in here. I will be using an M3 by 20 socket head from the other side to combine the two parts together. Once that is done, the next thing is to assemble the actual locking mechanism. So the actual locking mechanism is based on this locking piece that uses two V6 nozzles to tie into the clamp on the tools. So we can just take these two nozzles and thread them into this piece there. Next, we take this piece, keep it on the side, and then there is this other piece which is like a dog bone that will sit on top here. So we need to have two M3 by 40 screws that go into the slots on this piece upside down. So the threaded part needs to be on the other side, and the head needs to be on the inside of the slot. So we have one here, and then we have the second one in here, take these two, then we take this nozzle piece that we have, and we put it into the slot, trapping these two pieces, these two M3 screws. Now we will take another M3 by 35, I think, and put it from up here. We'll take a spring, this is the tricky part here, it takes a couple of tries, and we will take an M3 T-nut and just compress the spring and thread it down to apply pressure onto thread it a bit. Now that that's done, we can now take the wishbone piece and thread it into these two screws that we had inserted. So we just need to make sure that both of these remain on the same size here. So essentially they should be equally tight. I'm not sure if you can see it in here, but they are more or less equally on the top. The way that the system will work is that there's going to be a lever in here that is going to press this down. The tool is going to come in and then it's going to clamp back in here. So that is what we'll do next. So next, now what we have is we have this lever or the cam that needs to sit like this. So this cam in here, it needs to sit with the smaller part on top of the dog bone and the longer part protruding towards the front. This is where the servo eccentric horn will actually push it up or down. So now what we do is we take an M3 by 40 yes, let's check and make sure I have an M3 by 40 somewhere here. I think this is M3 by 40, yeah. So yeah, that should do. So we take this, we bring the hole in line with this is a bit tricky part because you don't have any leverage in here to actually push it down. So So now we just thread this in. I think there's some loose plastic that is stopping us from actually pushing it in, so we will just thread it from the other side to get rid of any loose plastic that is there. And open the hole up. Okay, so got rid of that piece of plastic that was there. Take it out again, and now we can actually assemble the cam onto the tool locking mechanism. So again, we position our cam, make sure that our hole on the cam is lined up, and let me just push it through. Yeah, there we go. So now the way the whole thing is going to work is like this. So if you see, when it opens up, that is the basic operation of the clamping mechanism there. Now that we have the carriage and the toolhead locking assembly both assembled, we can go in and put both of these things together. So the way that they actually come together is, we take the carriage, we take the toolhead assembly, and they fit into each other like this. Then we have M3x12s that go in from this side into the heat set inserts on the toolhead locking mechanism. Then we take the other M3x12 and lock it on this side as well. So this is just, I'm putting it together on the table right now, but when we install it onto the carriage on the gantry, they will have to be taken apart again, and then first the carriage gets installed, and then the locking assembly comes in from behind and gets clamped up here. There are two other M3 by I think 8 or 10 nuts socket heads that actually go in here on these two heat set inserts, so as to kind of make it restricted, make the toolhead assembly restricted and clamp to the carriage from both sides. Now the next thing is for the stepper to come in like this, and the eccentric horn to be installed here, which will actually move this up or down, and based on that movement up or down, you'll see this clamp opening up and down. This clamp is what holds the tool in place, along with two M4 rods that go in here, which align everything together. We will look into how to align these with the tool head or the individual tools, but this is like the triangular alignment that happens, and the clamp actually happens in here when the cam actually gets pushed up or down. So that is how the toolhead assembly is going to be put together. When we go in and put it onto the carriage, it will be more self-fitted. So that was a detailed guide on putting together the X carriage and the tool lock mechanism. I hope you guys enjoyed it, and you will consider building one yourself. In the next part of the series, we will be going through the actual assembly of the tool itself, as well as installing the carriage that we assembled in this part of the series onto the X gantry. In subsequent parts, we'll actually be looking at how to mount the tools onto the back extrusion of the CoreXY mechanism, as well as the alignments between the carriage and the individual tools. The series will also deal with all the software configuration and the wiring configuration that is needed to get such a project operational. So I hope you guys stick around for the next part of the video in series.